All right, welcome back. We are continuing on with the 2012 CIMC. We're just going to jump right into our next question, which is question number 4. Okay. So we're given a little bit of a diagram. In the diagram, angle AFC is 90 degrees. Here is AFC over here. And it has been labeled 90 degrees, so it's one of those diagrams. We're not going to have to relabel things. Point D is on the line AC. So here we have a triangle. It's a right angle triangle. That might be of use to us. We have a point D here. And D is such that the angle EDC is 90 degrees. So right now we're already thinking, okay, well that means this one over here is 90 degrees as well. ADE. And we're given some information about the lengths. CF is 21, which they've labeled for us. AF is 20, which they've labeled for us. And ED is 6. Determine the total area of the whole quadrilateral AFCE. Okay? So it's best for us to start by drawing our own diagram and tinkering with it a little bit. Okay. So, what did we have here? We have, there we go. So we had a quadrilateral. It sort of looked like this. Composed of a small triangle there, bigger triangle, and then we split this one into 2 smaller triangles. At a right angle here, this was size 6, this was 20, this was 21. Okay, and we were asked to determine the total area of this quadrilateral. Okay, now it's common with questions like this that what you're going to do is not actually be able to get a formula for the whole quadrilateral or the whole geometric shape that you're talking about. With questions like these, what we're going to be doing is we're going to be breaking this up, quadrilateral up into smaller bits, finding the area of each of those, and then being able to add them up and get the total area of the quadrilateral. So right now I'm seeing 3 triangles. Okay? This one here, and this one here. Okay? Notice how I have the base and height of this triangle, and I have a height for these 2 triangles, so I might be adding up the areas of 3 different triangles. Okay? So we'll see where it goes. Now immediately what I'm attracted to is the fact that we have this 20, 21, and we have a right angle. So immediately we should be thinking, oh, Pythagoras' theorem. Okay? So we want to get as much information about this quadrilateral as we can before we start solving for the areas. Okay, so let's just take a look at this one right here, this 21, 20, and it's a right angle. So if we add C over here, we know that Pythagoras' theorem is a squared plus b squared equals c squared. Right, the legs of the right angle triangle, 20 and 21, if you square them and add them to each other, you get a square of the hypotenuse right here. So 20 squared plus 21 squared equals c squared. So Pythagoras' theorem, it comes up a lot, so you should be very comfortable with it. In fact, you can get so comfortable that you recognize that 20 and 21 form the legs of a Pythagorean triangle, a right angle triangle, and you might automatically be able to know, okay, this is going to be, you might be able to say what the hypotenuse is even without performing this calculation. Some really common triangles where this happens, 3, 4, 5. Everyone will eventually know. 3, 4 with the legs, 5 is the hypotenuse. Same with the 5, 12, 13, that's another triangle that people will just eventually know. But 20 and 21, we're getting higher. We might not be so confident. So what are we going to do? We're going to grab our calculator. Okay, calculators are allowed on this contest. If not, we could just work it out by hand. But what are we going to do? We're going to do 20 squared. That's 400. We're going to add it to 21 squared. That's going to be 441. Okay, we're going to get 841. Okay, 400 plus 441 is going to be 841. Okay, and then we're just going to pop the square root button. Oh, geez, where's the square root button on my calculator? Things to practice ahead of time. I don't seem to be able to find it. Doesn't matter. I know 841 square root, and you obviously will know a little bit more about your calculator. Just really wish I could find it. Oh, there it is. So square root 841, 29. Okay? It's one of those Pythagorean triples you will eventually get accustomed to, like 8, 15, 17 is another example. So you see 20, 21, you can perform the calculation, or you can just jump straight to the answer if you know it. Okay? Pythagorean triples, they come up a lot. Okay? So we know this is 841. So C is going to be the square root of 841, which either we know or we calculate is 21. Okay? If we weren't allowed calculators, how would we figure this out? Well, we might start guessing. We might say, okay, well, they're probably going to give me an actual integer number. And I'm looking at 841. What are some squares that I do know? And you should probably be familiar with squares like 25 squared, 30 squared, things like that. Okay? And you would know that 841, which is the target, that's the one we want, is less than 900, which is 30 squared. But it's greater than 625, which is 25 squared. I find it's a very good thing to know sort of the multiples of 5 squared. That way you can sort of easily place this if you don't know where it is. It's below 900, which is 30 squared, above 625, which is 25 squared. So if it is a square of an integer, it's going to be a square of 26, 27, 28, and 29. And because of how close it is to 300, I'm betting it's 28 or 29. And that's just a simple calculation away. We do 28 squared. Oh, no, it's not. 28 squared is, what is it? 700 and something. 29 squared, 841. So then we can easily figure it out. What is 28 squared? I want to say it's 784. It might be. Oh well. But the point is we have our 29. Okay? So we've got that worked out. So now we can actually just label that in our original. Okay? So now we ask, okay, well, how are we trying to break this up? How are we trying to get the area? Are we doing this big triangle and these two smaller triangles? Well, unfortunately, there's not enough information. There's not enough information to figure out what this leg right here is and what this leg right here is. All we know is that this distance is 6 and this hypotenuse here is 29. Okay? Doesn't seem like that's enough to solve the problem, but we don't have to split it up into the 3 triangles that we were given. We could split it up into this area and this area. Okay? So if we were able to figure out this triangle, so I believe that's A, that's E, that's A, that's F, and that's C. Okay? We could do the area of EAFC is equal to the area of EAC, so this smaller triangle that's sort of tacked on to our right angle triangle, plus the area of our right angle triangle, which is AFC. Okay? So then we ask, could we do that? Well, we can definitely figure out the area of AFC. That's this big Pythagorean triangle. We have the base, we have the height, so we can definitely figure out the area of that triangle. How about EAC, this other triangle? Well, we have the base for it. It's 29. We just calculated that. And we have the height, that's 6. Okay. So it's 1/2 base times height. So base 29 times height is 6. And then our other triangle, 1/2 base times height. Base is 21. Height is 20. Okay, now we can either multiply these out by hand, or we can get our calculator once again. Okay, so we could do 29 times 6 divided by 2. Okay, and we'd get 87. And we can write 87 in here. So that's 3 times 29 is another way to look at that one. And then we could do 1/2 21 times 20. Okay? And that's going to be 210. So we could write 210 in. And if we're still not confident, we could add these up, but we can just add them by hand as well. 297. So if we wanted to do it by hand, we bring it over here. 0 plus 7, 7. 1 plus 8, 9. And then the 2. So no carrying at all. Didn't have to carry any 1s or 2s. And we got our final answer of 289. So we get the area of the quadrilateral is 297. We weren't given any units, and to be honest, no one really cares about units. Units are just there for you to double check to make sure you have a correct expression. But if we did, we might throw in a meters squared or something. But if we check, the original question has absolutely no units, so we don't need anything else. We're done. Area is 297. We did it by calculating enough information about two sort of sub-shapes, these two triangles, and then we were able to add them up together. Okay? And that concludes question 4. So we're over the halfway point of part A, and hopefully you will continue to join me as we continue on the 2012 paper.